This lesson is on absolute value inequalities, but actually we're going to start with a few examples of an absolute value equation, then we'll work our way up to inequalities. Let's take a look at this equation. Absolute value x, let's say, equals 3. Now, what could x be here to make this equation true? Most people would say, well, if x is 3, then the equation is true. After all, the absolute value of 3 is 3. But there's also another answer, and that is negative 3. Because if I plug negative 3 in, if I plug negative 3 right in there for x, the absolute value of negative 3 is also equal to 3. So it actually has two answers, and that's it. Two answers, two solutions. And so what I'm going to write here on the side is the pattern that we've discovered here, and it looks like this. If you have the absolute value of x equals some number k, and actually it has to be for a positive k. If the absolute value of x equals k, then we have two solutions. X will equal k, or it will equal negative k. Two solutions. That's the pattern that we follow here. By the way, notice that, let me go back up here a bit. Notice that if I have k as a negative number, such as this, it doesn't work, it doesn't apply, because what number can I possibly plug in here for x, take its absolute value, get negative 5? It's not going to work. There's no number that I could actually plug in there and make the left side equal negative 5. And so this one has no solution. No solution. Okay, moving along here. Let's say I have x, absolute value x minus 3 is equal to 7. Now what I'm going to do is I'm just going to follow the pattern that we wrote down. And the pattern was this in here will equal 7, or it will equal negative 7. X minus 3 will equal 7, or x minus 3 will equal negative 7. That's just the pattern that works, and we're going to follow it. That's going to give me two answers. If I solve this one for x, I get x equals 10. And if I solve this one for x, I get negative 4. And you could easily check these that they're going to work. If I plug 10 in here into the original here, 10 minus 3 is 7, absolute value is 7. But negative 4 also works. If I plug a negative 4 right in there, negative 4 minus 3 is a negative 7. You take its absolute value, you get 7. So two solutions. If you want to write it in our set notation, the two solutions would be negative 4 and a positive 10. Here's another example of this. Absolute value of 2x plus 1 equals 3. Okay. I'm going to do exactly the same thing. 2x plus 1 will equal positive 3, or 2x plus 1 will equal negative 3. Just solve each equation and you get your two solutions. 2x equals 2, x equals 1 there. Subtract 1 here. 2x equals negative 4, divide by 2, negative 2. So x equals 1 or x equals negative 2. Now, somebody might say, hey, this is an or statement. Don't I have to do that scratch work sort of thing that we did in the last lesson? And the answer here is no, because these are equations. These are not inequalities. X equals 1 and that's it. X equals negative 2 and that's it. So I don't have to worry about any of that graphing. I just take these as my two solutions, negative 2 and a positive 1. Two solutions to the equation. There they are. Okay, so that's how we solve an absolute value equation. Let's now take a look at an absolute value inequality, such as absolute value x is less than 3. Is it 0, 1, 2, 3? 1, 2, 3. Okay. Let's see if we can figure out what the solutions are. Notice that if I plug in 0 for x here, if I plug a 0 in there, the absolute value of 0 is 0, and that is definitely less than 3, so it is a solution. 0 works for the inequality. If I plug a 1 in here for x, the absolute value of 1 is also less than 3. 1 works. 2 works. If I plug 3 in there, does it work? Absolute value 3 less than 3? No, not quite. 3 doesn't work. Get rid of that. Barely, though. But what about 2.5? 2.5 would work. 2.5, even 0.5. What we find is that all these numbers between 0 and 3 make the inequality true. Also, -1 would work. The absolute value of -1 is less than 3. The absolute value of -2 is less than 3, and so on. Take any number you want between -3 and +3, and it's going to make that inequality true. Parentheses at 3 and -3 here. These are all the solutions to that inequality. Now this looks to me like x is between, oops, don't want the equal signs there, let's try that again. X is between -3 and 3. So what we've discovered here is that this has this as its solution. This is the pattern we're going to use in the next couple examples. I'll write it down on the side here in blue. If absolute value x is less than k, then the solutions will be x is between -k and +k. That's the pattern here. Let's do some examples of using that pattern. Absolute value x less than or equal to 2. Okay, according to the pattern, x is between -2 and +2. On a number line, that means I just shade everything between -2 and 2, which would look like this. Brackets. And in interval notation, that would be bracket -2 to 2 bracket. Those are my solutions. Any number between -2 and 2 will make the inequality true. It works. It is a solution. Let's try one that's a little bit more complicated. Absolute value of x minus 3 is less than 5. Okay. Following the pattern, which would give us this. This here, x minus 3, is between 5 and back here, -5. That's the pattern. Okay, now what I have to do is I need to solve that double inequality there for x. And that means I need x by itself in the center. So I've got to add 3 to each part here like that. And I get x is between -2 and 8. Those are my solutions, all the numbers between -2 and 8. On the ends we want here parentheses. Parenthesis -2 to 8 parenthesis. Here is one more of these. Absolute value 3x minus 4 is less than or equal to 11. Following the same pattern, 3x minus 4 is between negative 11 and positive 11. This is stuck between that here and the opposite. Now I've got to solve for x, so I've got to add 4 to everything. So that will be negative 7 less than or equal to 3x less than or equal to 15. Divide everything by 3. And we end up with x is between negative 7/3 and 5. Those are the solutions. All the numbers between negative 7/3 and 5. And there's our solution. Okay. Now, what do we do? There's one other possibility here, and that is, what if we have absolute value of x, let's say, is greater than 3? Well, let's see if we can figure out the solutions here. If I plug 4 in for x, that makes the inequality true. The absolute value of 4 is greater than 3. 5 works. 3.5 works. What we would find is that all the numbers that are past 3 are solutions. And also these numbers out here on this end would also work if I plug them in. For instance, negative 4, the absolute value of negative 4 is greater than 3. So I have shaded all the solutions to this inequality. Notice that there's 2 pieces to it. This over here is x greater than 3. This over here is x less than negative 3, and this is an OR statement. So we have our pattern. Let me write it here on the side. If you have the absolute value of x greater than some number k, some positive k value, then the solution to this will be x greater than k, that's this part right here, or this part right here means x is going to be less than, and it's the opposite of that k, negative k. That's the pattern. Greater than k or less than negative k. Let's see if we can use this pattern in an example. Absolute value x minus 2 is greater than or equal to 5. Okay. Absolute value greater than. So I'm going to use the pattern that I had just written down. And it said that this in here, x minus 2, will be greater than or equal to that 5. Basically, it's how it's written out without the absolute value signs. Or, it was an or statement, x minus 2 is less than or equal to that opposite, negative 5. That's how we would correctly follow the pattern. Okay, so that's what that absolute value inequality means. I now need to just solve each part for x. This would be x greater than or equal to 7. This part over here would be x less than or equal to negative 3. Those are the solutions. Let's graph it on a number line. I'll do some scratch work here just to be on the safe side. Greater than or equal to 7 are these numbers. Bracket. Less than or equal to negative 3 are these numbers. It is an OR statement, so remember, you just keep everything that was shaded. This and this. In our interval notation, the solution is negative infinity to negative 3 bracket, union bracket 7 to infinity. Let's do another one like this. These tend to be difficult for a lot of students, so let's do another here. absolute value x plus 3 is greater than 1. Okay. Following the pattern, x plus 3 is greater than 1, or x plus 3 is, I think of it as switching that and that, less than negative 1. There it is written out. Now once again, I'm going to just solve each one for x. Let's fix that. This is going to be x is greater than negative 2, or x is less than negative 4. Scratch work. Greater than negative 2 are these numbers. Less than negative 4 are these numbers. It is an OR statement, and so I just keep whatever's been shaded, and it would be this and this. Interval notation, negative infinity to negative 4, union negative 2 to infinity. Okay, couple quick things here just to mention now. And that is, what if we have, for instance, absolute value x, let me change that, absolute value x minus 3 is greater than negative 5. Now we'll also compare it to this. Absolute value x minus 3 is less than negative 5. Notice that we have a negative number on the end there. When is an absolute value greater than negative 5? An absolute value is always positive. This is always positive. So, when is it greater than negative 5? Always. In other words, no matter what number I plug in for x, this is true. It is true for all x. And so, the solution is any number at all. The solution to this is negative infinity to positive infinity without any, not much work at all. Now, compared to this is an absolute value, which is always positive. When will it be less than negative 5? Well, you can't have a positive number less than negative 5. That's never true. And that means no matter what I plug in there for x, there's no answer, and so this has no solution. All right, and that's our first lesson on our absolute value inequalities.